So we have that the charges of my spheres are minus 50 nanocoulombs, which means that is minus 50 times 10 to the minus 9 coulombs. In the previous video, I just ate the minus when I was writing the information that was given to us in the problem. So now that we have all of our variables, well, let's try to do a bit of a diagram. We have our sphere here, sphere 1, sphere 2, right? So both of them, they have negative charges, which means that they are going to feel not attractive. They have negative charges, which means that they're going to feel a repulsion force, okay? This charge is going to be pulled away from this charge and vice versa. They want us just to focus on one of them and then calculate the magnitude of this electric force, as well as the ratio between the electric force and its weight. So that is what they are asking us to calculate and to do in this specific exercise, okay? So now that we have that, we can go and jump to the solution. Let's go and solve our exercise. And for that, I'm going to erase the wording of the exercise because we already obtained all the information that we needed from that wording of the exercise, okay? So for our solution or a step, we want to calculate Fe, the electric force, and what we're going to do is just apply Coulomb's law. Coulomb's law tells me that is equal to K Q1 Q2 over R12 square, right? And if we go and plug the numbers, this is going to be equal to K, which is 9 times 10 to the 9, 10 to the minus 9, no, 10 to the 9. This is 9 times 10 to the 9. And then this is going to be multiplying minus 50. Actually, we should write this in the bottom line because we were going to have more space there to put all our numbers. So K is 9 times 10 to the 9. Q1 is minus 50 times 10 to the minus 9. Because I have Q1 and Q2 are equal, actually I'm just going to make this 2 squared. And then I divide that by my distance, which is 2 times 10 to the minus 2 squared. That is what my electric force is going to be.